Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Dr. Muhammad Azrin bin Ahmad and I am a lecturer for BUM2123 Applied Calculus for section 17P. As you all know, for chapter 2, which is vector valued function, we will conduct it fully online because we would like to support self-paced learning under substitute blended learning initiative. As you can see from this screen, there will be 4 topics altogether under vector valued function. The first one, vector functions and space curve. The second one, derivative and integral of vector function. Thirdly, arc length and curvature. And last but not least, motion in space, velocity and acceleration. I'll be the one who will be responsible towards the lesson for topic 2.1, which is vector function and space curve. So do not worry because we will be using the module that we have used in the lecture class. So I'll be using this screen or in this split view mode so that you can access the notes easily on the left hand side. Meanwhile, I'll be writing something on the right hand side. So before we go further into vector valued function, I believe during chapter 1, precisely in topic 1.4, you have come across with vector notation. As you see in that topic, for vector, you are playing around with constant for component vector I, J and K. But this time around, the component of vector is no longer constant, instead some function. As you can see from here, this is the part where we try to define what does it mean by the term vector valued function. As you can see from here, we call this vector notation RT as vector valued function or vector function. So if you look closely, you can represent this vector valued function in terms of ijk or that pointy bracket. So in this case, you will be having a different function for the component function. Okay, let's say we have ft, gt and ht. So based on your observation, your vector valued function consists of these 3 component functions. As you can see from the module, the author mentioned that for each t, we regard RT as a position vector. If no restriction are stated explicitly or implied by the equation, when it will be understood that t varies over the interval from negative infinity until infinity. This is what we call the domain of the vector function. I believe when you come across with the term functions during your primary school, by right, the teacher will try to explain to you about domain of that function, because the domain will help you to understand how the function behave. And then we can somehow relate with vector equation of the line that you have studied in the previous topic. Okay, so let us learn how to define or how to determine domain of vector function. Then we will go to chapter 2.1, which is vector function and space curve. By the end of this section, you as a student should be able to determine the domain of a given vector function, find a vector equation and parametric equation that joins 2 points, and last but not least, sketch the graph, curve and orientation of vector function. So, when you try to throw back what you have learned in mathematics, by right, this is how we define domain and range of a function. Normally, domain will lies on the x-axis, meanwhile range will be at the y-axis. So before we try to determine the domain of vector function, let us learn about a few types of functions, because each function will have different domain, or there will be different way to determine domain of a function. As you can see from here, I believe you are familiar with polynomial function. Let's say I give you function ft, and this function ft will give you something like this, t to the power of n, where n belongs to some integer. So in this case, whenever you have t to the power of 1, t to the power of 2, t to the power of 7, by right, you can classify that kind of expression, and that kind of expression belongs to polynomial function. And then as described on the notes on the left hand side, you come across with term exponential function, and term exponential function is given something like, let's say I'm giving you this kind of function, gt is equal to e to the power of 2t or e to the power of 3t. So we name this function as exponential function. And then let us go and take a look at the other type of function, which function trigonometric function. And trigonometric function is defined as sine t or sine 2t or sine or cosine 3t. So this is an example or examples of trigonometric function. And then it has been stated on the notes, whenever you have polynomial or exponential function or trigonometric function, by right, the domain of these three functions is actually from negative infinity until infinity. And this is how you write the domain of trigonometric, exponential and polynomial function, which is dt is equal to t such that t ranging from negative infinity until infinity. Okay, this is important because you need to understand the type of function so that you can come with a good conclusion or with a correct conclusion, or else it will lead to wrong answer when you try to determine the domain of vector valued functions. Okay, we have learned about trigonometric function, exponential function and polynomial function. The domain will be from negative infinity until infinity. It means that you can choose any t, somehow towards the end your function will be defined. So let's take a look at the other function. We call it as rational function. When you have rational function is a function where you have function ft is equal to 1 over t. This is the basic function for rational function. So whenever you have a function in this form, you can call it as rational function, where normally the numerator part of your fraction will be 1, and then the denominator function is a function written in terms of function t. So in this case, as you can see from here, you can choose any value of t. By right, your function will be defined. Your function will be undefined when you choose t is equal to 0. Your function will be undefined. So no matter what, you have to make sure, in order for the function to be defined, your t cannot be 0. T is not equal to 0 will make sure your function become defined. So that's why when you try to determine the domain of rational function, this is how you write domain of rational function, such that t is not equal to 0. So let us try to experiment with whatever we have understand earlier, and then let's say I'm giving you this kind of question. Function ft is equal to 1 over 2 minus t. Determine the domain of this function. So first and foremost, you need to know what is this function. This is actually rational functions. So by right, when you have this kind of form of function, you need to know that the denominator cannot become 0, because when it turn out to be 0, your function will be undefined. So in this case, you have to make sure 2 minus t is not equal to 0 and t is not equal to 2. When you try to represent the domain of this rational function, what should you do? You will have function dt is equal to t such that t is not equal to 2. So it will give us meaning, that is, the domain of the function is every value of t except at t equal to 2. So let's us take a look at the next type of function, which is radical function. The basic example of radical function is actually function ft is equal to set t. Whenever you have this set notation, you can somehow conclude that that is a radical function. Radical function. Okay, as you can see from here, the function will be defined as long as t larger than or equal to 0. Why did we end up with this conclusion? Okay, let's take a look. If you have your the calculator with you, why don't you try to put any value of t as long as it larger than or equal to 0? You will see that you will get answer. For example, if you put set 0, by right, the calculator will give you answer 0. Or if I put set 4, I will get an answer which is 2. But what will happen if you put the value of t and you replace it with value less than or less than 0? For example, set negative 1. By right, it will lead to complex variable, which you want to avoid when it comes to this chapter, because there will be specific topic that can deal with complex variable. In your scope of lesson, by right, you want to avoid the complex part. So in this case, in order for the radical function to be defined, the value t should be always larger than or equal to 0. That's why to determine or to present the domain of any radical function, it will give you something like this one. dt is equal to t such that t larger than or equal to 0. Let us try to experiment with any other example because we understood the process already. So what should I do? Let's say I'm giving you this kind of function. Function ft is equal to 2t minus 3. By right, you will say that this function is actually a radical function, and then you must know that whatever value under the set notation, it should be always larger than or equal to 0, so that the function will be defined. So that's why we will take 2t minus 3 larger than or equal to 0, 2t larger than or equal to 3t larger than or equal to 3 over 2. And then the best answer will be t such that t larger than or equal to 3 over 2. What should I do right after this? So this is the answer for this question. Let's say I'm giving you another example. Function ft is equal to 5 minus 4t. What should you do when you have this kind of question? So try to use the same approach, which is you need to determine the domain of this function, right? So I will know that this is actually a type of function that belongs to radical function, and I understood that whatever I have under the set notation should be larger than or equal to 0. So that is the knowledge that I have earlier. 5 minus 4t should be larger than or equal to 0. 4t less than or equal to 5. t less than or equal to 5 over 4. So you will see that the inequalities will change from larger than or equal to less than or equal to. So if you don't have any idea how it works, maybe you can refer to Google about the properties of inequalities. So you will have domain of this radical function is equal to t such that t less than or equal to 5 over 4. So let's take a look at the last type of function where we name it as logarithmic function. Logarithmic function. So if you look closely at your module, by right, this is basic example of logarithmic function such as ln t. Okay, right now, if you listen to my video, why don't you try to grab any calculator? Okay, I would like to ask you to try to calculate ln 0. Do you get the answer for ln 0? By right, if you punch in your calculator, the answer will be math error. Why don't you try to punch in ln negative 2? Do you get the answer for ln negative 2? No. It will give you math error. So if you still remember what you have studied during your upper secondary school, by right you will have the reason why when you choose value t is equal to 0 and value t is equal to -2, it will give you math error. So right now, if you choose any value greater than 0, not including 0, you will get the answer for in your calculator. So right now we have a conclusion that in order for this logarithmic function to be defined, the value t should be always larger than 0, not including 0. This is the only way in order to make sure your logarithmic function defined. So what should I do next? This is how I represent the domain of logarithmic function where t such that t should be always larger than 0. Okay, so let us try to solve several examples. Maybe I give you this kind of question. Function ft is equal to ln 2t minus 7. So why don't you try to solve this question on your own? So right now, since there exists ln notation inside your function, by right you can deduce that the given function belongs to logarithmic function. So you will know that the argument of logarithmic function should be always larger than 0. So that is the only way that will make sure your logarithmic function to be defined. So what should I do next? I will have function t is equal to, so what should I do now is that I know that 2t minus 7 always larger than 0. 2t larger than 7, t larger than 7 over 2. Therefore, my answer will be t such that t larger than 7 over 2. Okay, let me give you another example. Maybe function ft is equal to ln 5 minus 2t. Again, this example is actually belongs to logarithmic function. What should I do next? I understood the argument of my logarithmic function should be always larger than 0 in order for this function to be defined. Therefore, I will have 5 minus 2t larger than 0. By using the properties of inequalities, I will have 2t less than 5, t less than 5 over 2. So in order for this function to be defined, the domain should be dt where t such that t less than 5 over 2. I hope you really understand how to determine domain of this function. Whatever we have discussed earlier is actually we try to recall back how to determine domain of any type of function. In the next video, we will learn on how to determine domain of vector function.